Okay, so now I want to determine the area of the region bounded by the graphs f of x equal 2x and g of x, equals x to the 3/2 over the interval from 0 to 4. So I can graph f of x equals 2x pretty easily. So 0, we're at 0, it's just linear. The slope is 2, so at 4 we're going to be at 8. Okay. And then this graph, x to the 3/2, also is going to go through 0 here, so this is 2x. And then at 4, the function is also at 8. Let's take a look at the graph of that. X to the 3/2. So it looks kind of parabola-like. So it'll be here to here, and it kind of goes like this. Okay, and so we have a graph that looks like that, and so this green one is x to the 3/2. Okay, and so I can see if I want to integrate this, that if I look at a slice here, and the top of my slice is going to be on the function 2x, and the bottom of my slice is going to be on the function x to the 3/2. And so if I want to integrate, I want to add up all of my slices from x equals 0 to x equals 4. And the width of my slice is my dx, and the height of my slice is going to be 2x minus 3x to the 3/2. So 2x minus x to the 3/2. So that's the height of my slice, and then the width of my slice is dx, and then I'm adding up all the slices from x equals 0 to 4. Okay, and so now I just need to compute this integral. So an antiderivative of 2x is x squared, and an antiderivative of x to the 3/2, I'm going to add 1, so I'll get x to the 5/2 and divide by the new power, so 2/5. Oops, that's a 5th. Okay, and I want to evaluate that from 0 to 4, so I'm going to plug in 4 squared minus 2/5 times 4 to the 5/2 minus, and if I plug in 0, I'll just get 0, minus 2/5 times 4 to the 5/2. So I get 3.2. So 3.2 is the area of this shape here. So the next one says, suppose the region between those two graphs is rotated around the x-axis. So in other words, I want to take this thing, this solid that I have here, and I'm going to rotate it around the x-axis. And so it's going to look like this. Right, so it's going to look like kind of like a trumpet that will. And so if I think about that slice, what's that slice going to make? It's going to make a disc here. Okay, and so that little disc that I've made, well, it's a washer really is what it is, because it has the middle of it is cut out. So if I think about the volume of that washer, I can set this up. So I want to add up all those little washers. And again, I'm adding up all the washers from x equals 0 to x equals 4. Okay, and the volume of that washer is going to be the area. So it's going to be, I have this outside radius and this inside radius. And so the outside radius goes from the middle up to the blue function, which is 2x. So 2x. And then the inside radius goes from the center up to that blue function, which is 3x squared. So this outside circle here is going to be pi times 2x squared minus the inside circle is this little green guy, and the area of that is pi times x to the 3/2 squared, and all of that is multiplied by the width of my little washer, and the width of that is dx. And it says I want to set up the integral, but do not evaluate. And so there it is. So this here is the area of that blue disk, and I'm subtracting off the area of that green disk, pi r squared. And then that would be the area of this blue washer minus the green. And then I want to multiply that whole area by the width of my washer, which is a dx. And I'm going to add all those up from 0 to 4.